Hi guys, and welcome to the very first flipped classroom lesson. Now, hopefully you're watching this before I get back from camp, sort of towards the end of week 2, because listening to this first video is going to be crucial to our first lesson back in week 3. If not, you're going to be a little bit behind the 8 ball, but we'll sort that out when you get to school. Now, the chapter we're going to be looking at this for the next couple of weeks is called Algebra and Linear Equations. It's chapter 2 in your textbook. And what we're going to be looking in today's video is operations with pronumerals. Now, just to recap a little bit, hopefully you are fully aware of what a flipped classroom is. But if you missed out on what I was saying in class, basically a flipped classroom is where you end up going home and watching these videos on your computer, where I will teach you the basic concepts of what we're going to be teaching in class the next day. When you come to school the next day, what's going to happen in class is instead of doing all of those examples from the booklet up on the board, we're going to spend a lot more time together as a class working through the content and spending time a little bit more one-on-one, or maybe even in pairs or groups, going through the examples from your textbook, giving you more time to voice your concerns and queries about stuff that you may have been stuck on. Another benefit is you have the opportunity to, of course, rewind or replay or watch this video as many times as you want, well, probably only once, to make sure that you completely understand the concepts. For some of the harder topics that we went through last year in Year 9, I know that it's very hard with the limited time that we have in class to get through everything that we wanted to learn in such a short amount of time, and sometimes you can feel like it's just too much. There's so much information and you can't take it all in, and then the bell goes. So hopefully this will give you another opportunity to slow things down, revisit material, and you can watch these at any point in time because they're just going to be on YouTube. So let's get into this first lesson with operations with pronumerals. Now, to start this chapter off, we need to revise a little bit of the terminology that we had a look at in previous years that helped us understand how to work with our algebraic terminology and our sentences and whatever's going on here. This particular example can be found on the very first page of your booklet, right up the top. And we're going to use this to break it down what exactly every piece of terminology means. So, to start off with, if we have a look at this whole example, every single piece inside the bubble, this is what we would refer to as an equation. The reason why it is called an equation is simply because of this equals sign. Because that equal sign is present, it makes it an equation. So to help you memorize that, I know that these words are very similar. An equals has an EQU in it, and so does an equation. Both of those words are very similar, and together they represent the same thing. Equals equation. Make sure you keep that in mind. Okay, now if we were to split up this example here, and we were just to look at the left-hand side here and the right-hand side, and we'll just forget about the equal sign and pretend that doesn't exist for now. If we have a look at our next piece of terminology, which is second on the page, if we have a look at the right-hand side and we have a look at the left-hand side, both of these are examples of expressions. Now, an expression and an equation are very similar except for one important aspect, and that is an expression does not have this equal sign. Both of these groups on their own are called expressions. As soon as you add in the equal sign, it suddenly turns into an equation. Now, if we separate these groups down a little bit more into our individual groups that are on here, the 3xy, the 2x, the 7y, the 12x, etc., this is the next term, the next piece of terminology. And in fact, that is called a term. Each of these individual groups, separated by the plus sign and the minus sign here and here, each of these groups are called terms. And that brings us to our very last piece of terminology, which is the coefficients. The coefficients are just the numbers that come in front of each of our little groups here. For example, I could ask you, what is the coefficient of the term x? Now, you would have to look at this example and go, okay, well, here's the x. The number in front of the x is 2. So the coefficient is 2. Over this side, here's another term with an x in it, and this would be called the coefficient of 12 over this side. I hope that clears things up a bit. Don't forget, you can always ask questions when you come back to school. All right, moving on. Now that we know this terminology, we can start doing our operations with the pronumerals. Now, there's a few operations, just your 4 basic ones, your addition, subtraction, multiplication, and division. Now, where like terms come in is with your addition and subtraction. But let's quickly remind ourselves exactly what like terms are. If I had, for example, a term 3a, or 3q that looks like, and another one that had 4a in it. Now it says up here that like terms are terms that contain the same pronumeral and can be collected in order to simplify an expression. So you'll notice in these two terms here, they contain the same pronumeral, which is the letter A. That means I can add these two guys together or even subtract them to simplify my algebraic expression. Now that can only happen if the terms in my question have the same pronumeral. Now where some people get stuck is if I have one over here, if we go back to 3a, but the second one is 4a squared, some people still think that you can add and subtract these two because they have the same letter. But we can't, because the 3a term, the pronumeral is a. For this term over here, the 4a squared, the pronumeral is in fact a squared. They are not the same, and so we can't actually do anything with it, and it stays the same. So don't forget, like terms must have the same letter. It doesn't matter whether it's MN or, for example, let's put another one up on the screen. It doesn't matter if it's 2MN and you're adding 4NM. Doesn't matter that these letters are in a different order. They are still like terms if they contain the same letters. As soon as I add a squared up here though, these are no longer the same and we cannot add them. It's very important with addition and subtraction that you remember that concept. Okay, let's have a look at a few examples. These examples are found in your booklet that hopefully you've taken home with you. And the following examples are just starting from number 1. They should correlate with what you see in front of you in your booklet. In each of these cases, we're just going to simplify as much as possible, remembering that we have to follow the like terms rule, and then we'll get to a few more tricky questions later on. Okay, so first of all, our first question is 7y plus 8y. Notice that in each of these terms, once again, the letters are the same, so we can in fact add them together. Now the easiest way to do that, if we've got 7 here and we've got 8 here, when we add them together, just like on your calculator, it's going to equal 15y. Because we've got 7 plus 8 equals 15. Okay, let's have a look at number 1b, a little bit trickier. Now as soon as you start having a look at questions which contain more than one letter, I explained this last year, but what I like to do before I begin is get either a highlighter or a pen and highlight or draw shapes around the like terms. So if we start off at the beginning, our very first term is 6x. So I'll go through and look for another term which has a like term, which is an x. And here we go, here's one minus 3x. So I'll draw a box around it to highlight the fact that these two guys belong to each other. Once I've found all the x's, I'll go back and see what else is left. So the next term that I haven't highlighted is the plus 8y. So I'll look through and yes, there's another y at the back and I'll circle that. So now I've accurately displayed what are the like terms, and that will help me solve the question. So let's start off by doing the x's. We've got 6x and we're going to take away 3x. So we're going to be left with 3x. And I apologize for the writing, I have to use my mouse. And the second term, we are dealing with y's here, plus 8y, and we've got plus 7y over here, which is exactly the same as what we did up here. So we know that the last term is going to be plus 15y. Pretty straightforward. Okay, let's have a look at C, and we'll start highlighting our terms which are the same. So the very first one in 1C is a term which has the letters M and N in it. If we have a look through the rest of these, we'll see that this very last term has an M and an N. Even though they're the wrong way around, they are still considered like terms because they contain the same letters in it. Okay, let's have a look at the rest. We've got a 2N here, but there's no more N's. So let's have a look at our next one, which is the minus 5M. Again, these don't actually have any M's in it, and so our final answer, once we collate everything together, let's start off with the Mn. So 3 plus 8 is 11 Mn. Then we've got our plus 2n, and finally the minus 5m. And that's it. We cannot simplify this expression any further. Okay, let's have a look at the next one now. You should be getting the hang of it. So our very first term is 3a squared b. Let's have a look at the rest. There's no more a squared b's. There's an ab squared, but that's not the same. And then we've got an AB. That doesn't work. Okay, so there's no more. Let's move on to the second one. Here's plus 4ab squared. And the only one remaining doesn't have a b squared. So that means that all of these three terms are different from each other. Now, when you see a question like this, it's important that you don't leave it blank. Please write something like NA can't be done, or write the sentence can't be done, or even just rewrite the question to show the fact that you can't actually change anything. Other than that, this question is completely done. Okay, so looking at this question again, we've got 7y squared here. Again, if we have a look at the rest of these terms, we don't actually have another term with a y squared in it. So that's just left by itself. So moving on to the next one, we have plus 3y here. And we also have a plus 6y over here. Good. So we've got a couple of terms which have like terms, which means that the remaining one is going to be minus 3x squared. So that's going to be left all by itself. Okay, so let's go to our answer now. We've got 7y squared. That's all by itself. So 7y squared. Let's do our y's now. Plus 3 plus 6y is plus 9y. And then our last one is just minus 3x squared. All right, let's try and rush through this last one. The answer to this one, let's see, we've got 2a squared b. No more a squared b, so that's going to stay there. 2a squared b. Then we've got minus 44ab squared. So minus 44ab squared. And then we've got minus 9a squared. And then we've got plus ba squared. Now what I want you to do is I want you to come into school tomorrow, and our very first lesson that we do, I want you to tell me what mistake I did in this particular question. What did I do wrong? Okay, let's move on to the next example. This is example number 2. And this time, instead of adding and subtracting terms, we are going to be multiplying and dividing them, which is going to change how we do things. But it still involves the same 2 steps, which I'm going to give to you now. So let's have a look. When we are multiplying and dividing our terms, the best way to approach it is first deal with the coefficients, which remember is the numbers that are out the front, and then deal with the letters. So with this particular example, we have a 2, which is being multiplied by 5. Now we should know by now that that just equals 10. Now when we come to our letters, back in year 7, one of the things that we taught you in the algebra chapter was when we multiply two letters together, to simplify that, what we can do is actually remove the times sign and write it as AM, just smushing the two letters together. So keeping that in mind, our answer is just simply going to be 10 AM, which, let's try and make that look a bit neater. That's horrible. All right, so 10 AM. Okay, moving on to the next question. Here we've got 3, but we're still multiplying them all together. So first things first, make sure we do the coefficients first. 3 times 4 is 12. And then what's the number that's in front of here? Remember, if there's no number, it just means there's one of them there. So 3 times 4 times 1 is 12. Then with the letters, it really doesn't matter what order that you put them in. I just like to put them as it's written here. So M, N, E. But if you wrote 12, E, M, N, that would work as fine. It's still correct. It really doesn't matter what order you put the letters in. Okay, C. Starting again, let's do the coefficients first. So 3 times minus 2 is minus 6, times 5 is minus 30. Don't forget, you don't have to do this in your head. You've got a calculator with you. So if you feel a little bit apprehensive about doing multiplication in your head, just whip out your calculator and you'll be fine. Okay, now let's do the pronumerals. We have X, Y, and Z. So at the end, we have X, Y, and Z. Okay, last couple of examples. 10A over 5. Now, when we put over 5, that's just a fancy way of saying divided by. And like these first 3 questions, all you need to do is deal with the numbers and then do your letters. Okay, so let's do our numbers. 10 divided by 5 is just 2. Now we've got an A, but there's no letters on the bottom to divide A by, so we can't do any cancelling. So the answer just stays 2A, with A remaining on the top. E is going to be a little bit different though. Now this is something that you may want to use your calculator for if you're not good with dividing fractions. On your calculator you'll know there's a button which you'd put your fractions in. It looks a bit like that. If you put 8 over 14 in your calculator, it will simplify it for you and give you the answer of 4 over 7. Now we're going to leave a bit of room on this side to put our letters. Again, let's have a look at A. There's A on the top, but there's nothing on the bottom to divide A by. There's no A that we can cancel it out. So that's going to remain on the top. However, with the B's, there's one B on the top and one B on the bottom. And remember, when we divide something by itself, that means it comes out to be the answer of 1. So we end up cancelling the 2 B's and they are removed. So we don't put them in our answer. Now on the bottom there's a C, but there's nothing on the top. So that C is just going to stay on the bottom. So our final answer is 4A over 7C. All right, last slide. Last 3 questions. These ones are going to be a bit tricky. Okay, another fraction. Remember, all we need to do is start with our numbers first and then we'll do our letters. Okay, so 32, first of all, divided by 16 is just 2. And we'll put our fraction bar there just in case some of these letters stay behind on the top and bottom. Okay, let's start with the A. There are 7, A to the power of 7 here, but there's only 3 on the bottom. So the 3 are going to be removed from the bottom and 3 are going to be removed from the top to leave us with A to the power of 4. So 1 is removed from the top and bottom until one of these 2 runs out of A's. And in this case, it's the bottom. 3 were removed here, 3 were removed from the top. Okay, let's have a look at the B's. Now the B's are just going to get cancelled out because there's 1 of each. And finally with the C's, there's 4 on the top and 1 on the bottom. So 1 gets removed here, 1 gets removed here to leave us with C to the power of 3. It turns out we didn't need our fraction bar after all. So our final answer is 2A to the power of 4, C to the power of 3. Okay, second last one. Here we go. 7 divided by 14. Now, if you put that in your fraction button, that will come to 1 over 2. And that will simplify it for you. Let's do the letters now. Now, this is on the top, remember, this is the numerator, and this is the denominator down here. So we've got 1m on the top, but 2 on the bottom. So this 2 now becomes 1. So we're left with 1m on the bottom. Now we've got 1n on the top and 1 on the bottom, so they just get cancelled. So our final answer is 1 over 2m. Remember, you just need to cancel out the letters off the top and bottom depending on how many are on the top and how many are on the bottom. Okay, last one. Again, you can use this fraction button for this. You put minus 7 over 21 in your calculator, and that will simplify it down to be minus 1 over 3. Let's do our letters now. So we've got 1p on the top, but none on the bottom. So that will just stay as the letter P. Now with the Q's, we've got 1 on the top and 2 on the bottom. So 1 will go from the top and 1 will go from the bottom, and there's still 1 left over. So that will just be placed on the bottom where it belongs. Now with regards to the R, there's 1 on the top but none on the bottom, so that will just stay where it is. Nothing happens to that. And so our final answer is minus 1 PR over 3Q. And that concludes our very first lesson. Obviously, this is going to be a bit of a trial period. I hope you enjoyed it and that you managed to write down your examples. Don't forget to come and see me in our very first class if you have any questions, and we're going to see how we go from there. Thanks for listening, and we'll see you in the very next lesson.